Welcome to the second tutorial of Pytest. In this tutorial, we will look at some of the functionalities Pytest provides. In Pytest, we can write tests using less boilerplate code. Why this? Because now we can assert using plain assert statements and subclassing of test cases is not required anymore. Let's look at this through an example. I have a test written in unit tests. Let's run this test. So you can see that unit tests ran just one test in 0.0 seconds. Now let's run this test using Pytest. So I don't need the import statement anymore. I don't need to subclass my test, so I can remove this as well. I don't need the self argument. And I can just use the plain assert statement. Let's run this. So you can see it says it collected one test from test_foo_less.py and it ran one test in 0.03 seconds. One of the features which Pytest provides is marking the tests. Once a test has been marked, you can either choose to run the individual test or run the rest of the tests. Now let's see how the marking works. So I have written a piece of code where I have defined two functions and written the tests for the same. Now let's mark the two tests. To mark the tests, I need to import the Pytest module. So I'll write py.import Pytest. Now I'm going to mark the first test with a marker slow. And the second with a marker fast. These markers are custom and you can give any name you want. Now let's see how the tests are run. So you can see it says it ran one test and it deselected one. Now if I want to run the test which is marked as fast, I can just write fast here. Similarly, if I want to run all the tests which are not marked as slow, I can use the not command. So this will run the second test which is marked as fast but not slow. Pytest also allows us to skip the test upon conditional checking using the built-in py.test skip if marking. Let's see how this works. So I have written a test and I've given it a marker to skip if the system platform is Win32, basically Windows. So as I'm operating this on Windows platform, this should skip this test. I also need to provide an argument which is a reason why this test was skipped. So let's just write something. Okay. Let's run this test. So you can see it says one test skipped in 0.09 seconds. So basically it did not run this test because we are operating on a Windows machine. If I make it, or if I delete the skip if marker altogether, let's run this again. it says one test passed in 0.03 seconds. So this way, the skip if markers can be very useful when working with uh, different environments and using the same set of test suits. Let's move forward. Now let's see how fixtures work in Pytest. The purpose of test fixtures is to provide a fixed baseline upon which tests can reliably and repeatedly execute. Test functions can receive fixture objects by naming them as an input argument. For each argument name, a fixture function with that name provides a fixture object. The fixture functions are registered by marking them with the @pytest.fixture annotation. Now, what fixtures are, you'll basically understand using an example. So, let's go through an example. So, I've written a test here where there are basically two test cases which are asserting if a particular word is present in the title of a website. I'm using Selenium WebDriver to open a website. Let's run this test. So, you can see it's opening the site. Okay, that was really fast. And now it's running the second test, and it says 2 passed in 11.32 seconds. So one of the important things about fixtures is that it allows the dependency construction of the test environment outside the test case, which is a very useful thing. Now I can also provide some arguments, custom arguments to this fixture. Like I can define the scope of this fixture. I can write scope, and I can define the scope to be a session. So let's see how this is different from the previous test we have just ran. So this should open both the website in a single session, and yes, it just did. You could just see that it ran two tests in 5.22 seconds, and that both the tests were in a single session. Now let's see some of the plugins that Pytest provides. Pytest provides with third-party plugins that extend the capability of it. Some of the plugins listed down here are the Pytest XDis plugin, the Pytest Django plugin, the Pytest Twisted plugin, Pytest Capture Lock plugin, the Pytest plugin for coverage reporting, and there are many more which are under development yet. So let's look at one of the plugin, which is the Pytest XDis plugin. So now here in the same code, I'm going to use the Pytest XDis plugin, which is for parallel programming. So here what we saw in the first test was that Selenium WebDriver opened one website. After it asserted that and the test was passed, it closed and another session was opened in which the second test was ran. After that, in the second phase, what we saw was we defined a scope for both the tests, and both the websites and the tests were opened one after the another in the same session. Now, if I want to have a speed up, I can use the Python XDis plugin to run both the tests simultaneously in two different browsers. Let's see how this works. So I've already installed the Python XDis plugin in my system. So to run the test using the Pytest XDis plugin, I can use the following command: py.test -n, and then I can give the argument, supposingly 2, which will run two parallel processes. You can give this argument up to the number of parallel different processors you have in your system. So I'm going to run the test for two processors for as of now. Let's run and see how this works. So this is going to be fast, so I'm going to show you that two tabs are open. So you can see the last two tabs are simultaneously open, and okay, it says two tests passed in 8.22 seconds. So this can give you huge speed ups when you have multiple tests going on running at the same time. One another plugin which Pytest provides, which is the Pytest coverage reporting. What coverage is basically it gives you a figure, a percentage, which says how much percentage of your code is actually executed by the test set. Let's see how that works. So here I've written a file in which I've defined 4 functions. The first function returns x plus 1, the second returns x plus 2, the third x plus 3, and so on. Now what I'm going to do is I'm going to write a test function, and in that I'm going to test func of 1. I'm only going to test the first function, I'm not going to test the other 3 functions. Now let's see how the coverage turns out. Following is the command to run coverage plugin. The first file is the file on which the tests are supposed to be carried out. And the second file is the test file. In our case, both are the same. So let's run this. So you can see that it gives a detailed output. It says suggests the name of the file, the total number of statements, which are 10, how many statements were missed. So it says 3. So basically the 3 statements are all the 3 return statements of function 2, 3 and 4. So our statement coverage is 7 by 10, the number of statements executed upon the total number of statements. Make some changes to these files and see how this turns out. So I'm going to define some variables. Now let's run the coverage. So you can see it says 3 statements missed out of the 12 statements. So basically it will take into account all the static variables which were defined above. Now let's include a statement in a function which is not tested. Now let's run this. So you can see the coverage dropped down to 60% because now in all 6 statements were missed. 2 from all the 3 functions each. Function 2, function 3 and function 4. So we looked at what fixtures are and how to use them. Now let's look at some of the inbuilt fixtures Pytest provides. Let's write a test. So here we are using the tmpdir fixture. What this fixture provides is an empty directory. You can operate any operations you want in that empty directory. So what I'm basically doing here in the test 1 is I'm making a file foo inside the temporary directory and writing hey. Let's write another test. We learned in fixtures before that every time a test method is called, a new environment is set up. So basically in this test 2, a new temporary directory is made and temporary directory.listdir will return null. So assert not null should pass the test. Let's run the test. So you can see it says 2 tests passed in 0.05 seconds. The next fixture which we are going to look at is Monkey Patch. Monkey Patch allows you to set up a virtual environment and set attributes in it. Let's see how it works. The first argument is the name of the environment, and the second argument is the type of environment. Now let's assert if this environment is present in the current OS. So you can see the test passes. So in this way you can set any kind of attributes which your test requires and are not provided. Now let's look at another feature Pytest provides, which is profiling time durations. If you have a large test suite which is running slow, you might want to find out which tests are the slowest. So we'll look at an example which we saw before, which is I've defined two tests here, test underscore 1 and 2. The first test asserts if a character is present in a string, and the second test asserts if a string is equal to another string. I've written another test, test underscore 3, which is not asserting anything but just passing. Now let's run and see which test turns out to be the slowest. The following is the command to sort the tests according to the durations. If I write duration equals 3, it will give me the top 3 tests which are the slowest. So test underscore equals to 2. So you can see it says test underscore 3 teardown occurred in 0.0 seconds, 0 seconds, 0 seconds. So all of them were really fast, and there was no particular difference between the 3 of them. Now if that is because all these tests are really small. Now if I write a huge test, then obviously it will take some time to complete. Now instead of writing this, I'm just going to add some delay to all the tests. Now let's see how this turns out. So you can see it gave the top 3 tests which were the slowest. Obviously test underscore 1 was the slowest because it had a time delay of 0.02 seconds. This test underscore 2 was the second slowest because it had a delay of 0.1 second. And the third test was obviously so fast that it was faster than the setup time of test underscore 2. Now let's see if I want to make it test time dot sleep 1 second, then obviously it will turn out to be the slowest test. And let's run the command again. So yes, you can see the test underscore 3 is the slowest, which takes 1 second to call. It gives you a detailed output, and test underscore 1 was the second slowest, and test underscore 2 was the third slowest. So in this way you can profile the time durations of your tests. Now let's look at another feature which Pytest provides. I have written a function here which is test underscore increment. Now supposingly if I want to test this function with multiple arguments, I need to write multiple tests. But instead of doing that, I can use a marking which Pytest provides, which is the parameterized marking. Let's see how this works. These are the arguments which the function needs. Sorry. In the next line, I'll give the arguments. So let's say if the first test which I want to run is 1 comma 2. So basically I'm giving the n as 1 and expected as 2. The next test 2 comma 3, and let's see three comma 5. Okay, so basically two tests should pass and the last one should fail. Let's see if this works. So you can see it says 1 failed and 2 passed. So in this way you can run multiple tests with different arguments for a single function without writing multiple tests for that. One more feature which we are going to see now is how to modify the traceback printing for all the tests. Let's see what I mean by this. So here I have written test 1 and test 2. The first test asserts if 2 is equals to 1 plus 1, and the second will assert if 4 is equals to 3 minus 1. So obviously the first test will pass and the second should fail. Let's run them. So py.test test underscore example1.py. So you can see it gives a detailed output of failures. So in the test underscore 2, assert 4 is equals to 3 minus 1 failed. Now you can see there's a whole lot of information available here about how the test failed. Now let's try to modify this traceback printing. So you can use the command --tb equals no. So this will not print the traceback at all. So you can see that it just showed 1 failed, 1 passed, nothing else. You can also use tb is equals to long. Sorry, not longs but long. You can also use tb is equals to short. You can use one-line tracebacks. So in this way there are a whole load of modifiers in which the different types of tracebacks can be modified.